All right, good morning, class. Now we have come to the end of chapter number 8, current electricity. We are doing unit C, electrical energy and power. If you'll remember, we are doing unit C, electrical energy and power. In the last session, we learned about electrical energy and electrical power. All right. Now, in the last classes, we saw that there are 4 different ways in which you can find electrical energy. That is W equals to quantity of charge into terminal voltage. W equals to terminal voltage multiplied by the current flowing through the circuit, that is I, and the time period for the flow of current. Then we have third equation here, W is equals to I square R T. Then we have fourth one, V square T by R. And we also learned that the unit of electrical energy is joule in the SI system. Then again we learned about power. You know power is rate of doing work. P is equals to W by T. Isn't it? We know the equation P equals to W by T. Isn't it? From that concept, we got the first relation P equals to QV by T. Second, P equals to VI. Third, power equals to I square R. And fourth, power equals to V square by R. And we also learned about the SI unit of power, that is watt, denoted by capital letter W. But you know that watt is a very small unit to measure the electrical power, isn't it? So apart from watt, we have bigger units of watt, that is kilowatt and megawatt, gigawatt, which I've already taught you in the last classes and also in chapter number 2 in this book, isn't it? Then after that, we learned about commercial unit of electrical energy. The electrical energy that we consume at our home or in any place is measured by a unit called watt hour and kilowatt hour. Are you getting my point? Now you know that power is equals to rate of doing work, that is P is equals to W by T, right? So from here we get that W is equals to P into T, isn't it? I have just cross multiplied. Okay, so you know the power unit of SI unit of power is watt, okay, and the SI unit of time is second. So the unit of energy here, okay, we are getting work done, we are getting as watt per second. So watt per second, so you are measuring the amount, that is power consumed by a device, electrical device, in seconds. So when you measure in seconds, is very less, isn't it? The amount of time is very less here, second. But when you are consuming electrical energy at home, you know the meter reading, the man who comes for the to take the reading of your meter, electrical meter, he comes in months, isn't it? After a month or after 2 months or 3 months. So that time period is very huge, because you know if you start to measure in second, the figure that you get will be very huge, a large figure. So you know that in a second, in a day, there are 3600 seconds. So please contama 24 hours ma you have 3600, in 1 hour, isn't it? 1 hour ma you have 3600 seconds. So imagine in 24 hours it will be multiplied by 24, and the man is coming after 3 months, that is after 90 days. So this unit, that is watt per second, okay, or joule, will be a very small unit, and it will give you a very huge figure after when you do the measurement of electrical energy in the unit or in the time of seconds, if you use the second as the unit to measure the electrical energy. All right, so to avoid that, we have a unit called watt hour and kilowatt hour. So that is why on your meter also, if you see the meter, you will see it is written on your meter also, kWh meter. It will be written on the meter, electrical meter that you have at your home. So it measures kilowatt, bigger unit of power, and hour, bigger unit of time. So kilowatt hour is a unit to measure electrical energy. Remember, energy नाप्ने है kilowatt. So kilowatt देखेर चाहिँ you might be thinking that it is used to measure power भनेर. No, kilowatt is the bigger unit of power, but kilowatt सँग time पनि छ यहाँ, that is hour. So kilowatt hour is the unit to measure electrical energy. What energy? Electrical energy. And also you can write this unit, commercial unit को electrical energy unit is watt hour. Okay, now we have last topic left in this chapter, that is called power rating. What is it? Power rating. So I have here taken 3 examples here of power rating. So we are now learning power rating of some common appliances, electrical appliances. So here I've taken one refrigerator, here I've taken a bulb, this is your bulb, and here I've taken a fan. You can see, you can see on any electrical appliances, right from your radio at home, television, or your iron, mixer, grinder, your speakers, your adapters to charge your phone, any electrical appliances, you can find this markings or power ratings mentioned on it. Now what is power rating? Now power rating has 2 things on it. One is the voltage, that is volt, another one is the power. So you will see these 2 things, that is V, and other one is the watt. So, so for example, here you see that on the example here on refrigerator, you see it's written 127 volt. So this refrigerator functions properly at a potential difference of 127 volt when it's connected at 127 volt. It is going to consume 205 volt. Are you getting my point? So that is the heater cord, let's say 205 watt consume गर्ने रहेछ. Similarly, the lamp of the refrigerator has 150 watt. So 150 watt consume गर्ने छ. Refrigerator itself ले चाहिँ 20 watt, freezer ले चाहिँ 15 watt. So this is what we call power rating. You will find this in each and every electrical appliances. Now when you come to fan, so fan ko pani, there is a label at the back of this fan. On the label it's written 220 volt and 30 watt. So this is power rating and this is voltage rating. Are you getting my point? So this you can find in each and every electrical appliances. Now let's come to the bulb here. On the bulb also you can see that it's written 110 to 13 volt and 150 watt. So this is what we call power rating. Power rating bhanekittikai you will find these 2 things mentioned on the electrical appliances. Now what does it mean? Actually, what does this mean? What does the power rating that is shown on the electrical appliances tells you or gives you? So it generally means that, suppose if I take the example of this bulb, it means that if I light this bulb at 110 volt, it is going to consume 150 watt of energy, electrical energy. So 150, you know watt means joule per second. So 150 joule of energy will be consumed in 1 second by this bulb when I connect it under the potential difference of 110 volt. Similarly, here this electrical fan here, which has a power rating of 230 volt and 30 watt, which means that when I connect this fan at a potential difference of 230 volt, all right, it is going to consume 30 watt of energy, that is 30 joule of energy in 1 second. Are you getting my point? So this is what our power rating gives us. Now let's see what does this rating of an appliances help us to find. See, rating of this power or rating of these appliances can give us 2 things. One is resistance, the other one is the current. Are you getting my point? Safe limit of current. Are you getting my point? Now if you see here, okay, you can see that you have one equation here, P is equals to V square by R, okay, and P equals to VI. So from here, okay, from using these two equations, we can get two things from the power rating of an electrical appliance. One is the resistance of the filament or the element that is used in the electrical appliance, okay, and the number two is the current, the safe current that has to be flown through the electrical appliances which we are using. Are you getting my point? So from those two equations that I showed you up there, we got that P equals to V square by R. So from here, when I make R as the subject, I'll get R equals to V square by P. Are you getting my point? So you saw there the bulb was 110 volt, okay, and it was giving 150 watt. These were the power rating mentioned on the bulb. So from here, I'll see that 110 into 110 divided by 150, isn't it? So 0 gets cancelled. So I'll get 1210 by 15. When I divide this, I'll get the resistance of that bulb. So that bulb has a filament. So suppose say this is my bulb, okay, so this is my bulb. So bulb has a filament here. So this filament is made up of some material, okay, which has very high resistance. So your filament ko चाहिँ कति resistance छ, that can be calculated using the power rating. Are you getting my point? So this is the equation which help us to find that. Now the other equation I showed you was P is equals to VI. Now if I make I as the subject, I equals to, I'll get P by V, isn't it? So here using the same bulb, I know the power of this bulb is 150, okay, divided by the potential difference at which I have to make use of this bulb is 110. So 0 gets cancelled. So I'll get 1.4, okay, and something ampere, isn't it? So this is my current. So this is ampere. So the safe limit on which the bulb can work properly or function properly is 1.4 ampere of current. So you want the basic current flow by when the filament may get damaged and the bulb may get fused. So these are the two things, okay, very important things that can be found out by the power rating. Are you getting my point? So now your assignment for today is to find out, okay, find out from this explanation, okay, the two information, okay, or the two quantities which can be calculated from the rating of an appliance. So power rating of a appliance bada chai, what are the two quantities that we can calculate? So that is question number 1. Question number 2 is, I have an electric bulb, okay, or you write this question, an electric bulb is rated as 60 watt dash 220 volt. What does this statement mean? So this is your assignment number 2. Okay, so these are the two assignments that you have to do today and send me in the evening. All right, is that okay?